Is cold fusion real or still a myth? Imagine a world where you could generate clean energy just by mixing certain metals and water at room temperature. That's the idea behind cold fusion, a concept that has fascinated scientists and skeptics alike for decades. Cold fusion claims to produce nuclear fusion, where atomic nuclei combine and releases energy, without the extreme heat and pressure seen in stars or traditional fusion reactors. Instead, it suggests this could happen at or near normal room temperatures, making it a potentially revolutionary energy source. The story begins in 1989 when two scientists, Stanley Pons and Fleischmann, announced they had created excess heat during an experiment involving electrolysis of heavy water with a palladium electrode. They believed this heat was a sign of nuclear fusion happening inside the metal. Their claims sparked worldwide excitement, but other labs couldn't reliably reproduce their results. Many scientists dismissed the findings as experimental errors or misinterpretations. The controversy caused cold fusion to be pushed aside and considered a scientific myth for many years. Despite the skepticism, some researchers kept testing the idea. Recent experiments have used different approaches, like loading deuterium, heavy hydrogen, into palladium metal through electrochemical methods. When high-energy deuterium ions are directed at this loaded metal, some experiments have detected small increases in fusion reactions, evidenced by the production of neutrons. Neutrons are a clear sign of nuclear fusion, so their presence suggests something unusual is happening. However, these results are modest. They show about 15% more fusion reactions than normal, but the energy produced is tiny, for too small to power homes or cities. Still, the fact that these experiments are repeatable and produce measurable signs of fusion keeps the curiosity alive. The environment inside the metal lattice seems to alter the conditions needed for fusion, sometimes called lattice confinement fusion. This idea hints that metals might create a special environment where fusion could occur more easily, even at low temperatures. While cold fusion has not yet proven to be a practical energy source, it remains a strange and intriguing area of research. The experiments are unusual, often involving metal sponges soaked in heavy water and zapped with electric currents or ion beams. The results are subtle and sometimes hard to explain, but they suggest that something unusual is happening at the boundary between chemistry and nuclear physics. In the end, cold fusion sits in a gray area, neither fully accepted nor completely dismissed. It challenges our understanding of how nuclear reactions work and keeps scientists questioning what might be possible in the future. For now, it remains a mysterious force that sparks curiosity and pushes the boundaries of what we think we know about energy and the universe.